Hi, in this video we're going to look at hydrolysis reactions. How do they come about? What are the conditions for hydrolysis reactions and what do they result in? If you find this video helpful, don't forget to share, like and subscribe and look out for new videos. Okay, so in this video we're going to look at hydrolysis reactions. Specifically we're going to look at hydrolysis reactions of amides and esters. So hydrolysis, so this is when we add water either in the presence of acid or in the presence of base. We add it to an ester or an amide. Usually we're talking about secondary amides. We can also have primary amides. So if we were to take our ester and we would add an acidified here, if we were to add water under acid conditions, we see we can make an alcohol and carboxylic acid. But if we added water under base conditions, we would add the alcohol and the carboxylate ion. So there's a wee slight difference between whether we add the acid or the base, and it's important that we remember these. Same with a secondary amide. The slight difference here is when we add the base, okay, again we get the carboxylate ion, we get the amine produced, but when we add the acid we get the aminium ion, okay, that's the NH3 plus ion, and we get this alcohol produced. So this is a summary of the type of reactions we need to be able to understand, and let's look at some more detail. Okay, so esters can be hydrolyzed by dilute acid, and we can use dilute base as well. If we use acid, the carboxylic acid is produced and the alcohol. If we use base, the carboxylate ion is produced and the alcohol. So what do I mean by that? Well, if we take the ester and we add and we carry out hydrolysis, notice that hydrolysis is an equilibrium reaction. So even though we produce the carboxylic acid and the alcohol, it might not be to completion, so there will still be some ester left, and depending on the conditions it might go back to the ester. Now if we add water in acid conditions, we produce a carboxylic acid. Now the reason we produce the carboxylic acid is to do with, if the carboxylic acid is in acidic conditions, it's not going to give away its proton, so it will stay as a carboxylic acid. Alcohols will stay the same whether they're in acid or base conditions. However, if I take this ester now and I put it in base conditions, I will break this apart the same as I did. Now because it's in a base condition, and it's at equilibrium, if it's in a base condition, you can imagine that if this was a carboxylic acid, which it would have initially done, it would donate its proton to the base to produce water, because it is a base and this is an acid. Okay, this isn't an acid anymore, it's the carboxylate ion because it's already donated its proton. So when we are in a basic solution, basically an ester will go to a carboxylate ion and the alcohol, because the alcohol is the same in both acid and base conditions, but carboxylic acid will be an acid in acid conditions and a carboxylate ion in base conditions. Okay, so let's see if we can remember what I've just said in the last slide. So if we have an ester and we carry out hydrolysis, can you just stop this now and see if you can draw and name the products from acid hydrolysis and the products from base hydrolysis? Remembering, acid produces the acid, base produces the carboxylate ion. So here we go. Acid produces the carboxylic acid, this one here, we break it straight down the middle, and we produce this methyl propanoate, 2-methyl propanoic acid, not propanoate, plus we have this ethanol that's produced as well. If we carry it out in base conditions, we're going to produce the carboxylate ion, which is 2-methyl propanoate this time, and we're going to produce the alcohol ethanol. Sometimes we'll write this just methyl propanoic acid or methyl propanoate because the methyl can only come off the second group. Okay, so amides can also undergo hydrolysis. And if we look at secondary amides, it's going to break apart here, right? We're going to add an H and an OH, but not really. What happens is, because it's in acid conditions, the carboxylic acid will stay in an acid, but the amine, because it's in acid conditions, will have an H plus donated to it, so it becomes this ion here, this aminium ion. No, so I know it's a bit tricky to say. So a secondary amide goes to a carboxylic acid in acid conditions and an aminium ion in acid conditions. You don't need to remember the name of this ion, you just need to remember that if it's in acid conditions it goes to NH3+. If it's in base conditions, we're going to have the flip. This is going to be flipped around, so we've got the secondary amide group here breaking apart in the middle. We are going to have the acid, because it's in base conditions, will become the conjugate base, or in this case it is the carboxylate ion, and we're going to have the amine just stay as the base, the amine, because it is sitting in a basic solution. Okay, well, let's see if we can write the answers for these reactions here. So if you want to just pause, you can write the reactions for the hydrolysis under acid conditions. Do you remember the following? If we break apart the molecule here, because it's acid conditions, the carboxylic acid will stay as a carboxylic acid, methanoic acid. The amine, however, will have a proton donated to it, so it will become the aminium ion. Oh, this name then would be called ethanaminium. Kind of weird, eh? We don't need to know that name. Ethylaminium ion, that's what it would be called, or ethanaminium ion. If we did the hydrolysis as a base, the acid would lose its proton to the base, so it would become the conjugate base, or what we would call as the carboxylate ion, or because we're using the meth here, it's going to be the methanoate, sorry, why did I say carboxylate? Methanoate ion. And we are going to produce again this amine, which this case is ethanamine. And those are the summary of hydrolysis reactions on amides and esters. So finally, if we go back to what we had for a start, if you want to just stop and draw this reaction scheme to see if you've remember all the stuff we've learned in this video, write down the ester and the secondary amide and see if you can write the products in the two different conditions. So at the top here, acid conditions for the ester, hydrolysis, base conditions for the ester, base conditions for the amide, and acid conditions. The ignore here that the arrow is just one direction. This is not an arrow for an equation, it's just showing what it's going to. This would be equilibrium arrows if we were drawing a proper reaction for these reactions. So ester, it goes to acid conditions, the carboxylic acid here, this is ethanoic acid, and it's going to produce the ethanol, which is methanol. Base conditions, of course, this is no longer carboxylic acid, this is the ethanoate ion, but we still produce the same methanol. For this amide here, we can see if we break it down the middle here, we're going to have the carboxylate part here is going to be ethanoate ion, and the amine here is going to be propanamine, or propan-1 amine. Because it's base conditions, remember that we write this as a carboxylate ion instead of an acid, and the amine stays as a base. If we put it in acid conditions, of course, the acid is now a carboxylic acid, and the amine is now an aminium ion. Okay, so we put the plus and the extra hydrogen here. Well, I hope this video has been useful. and that you can go out now and answer some questions and on hydrolysis. The next video we're going to look at is some condensation polymers. And okay, if you've got to this part of the video, you've obviously watched all the examples that I had on those 3 questions. Hopefully this has fortified your understanding of geometric isomers and you are now well prepared to go and attack that exam. Good luck, and if you found this video useful, don't forget to like it, subscribe, and look out for new videos that I might put up by clicking that bell. See you later.